Hello, everyone. As Greta said, my name is Ryan Boyd, and I'm going to be talking today about how you can move from a relational database to a graph database, and in particular, Neo4j. My Twitter handle is RyGuyRG. You can feel free to reach out to there if you have any questions after this presentation. Hopefully you don't mind any dog pictures or whatever that I have on there, but feel free to connect, and I'm happy to help you through with your journey from relational to graph. All right, our agenda today, we're going to first start with talking about the origins of Neo4j as a company and a little bit about that information, about the company and the product that might be beneficial as you decide whether or not to move to Neo4j. And then going to go over the benefits of graphs in particular related to the benefits of graphs as you move from relational, and then talk about designing your graph model. Moving into some queries, show you some queries that are easier and better in Neo4j than a relational database, and also in particular queries that are faster in Neo4j versus a relational database. And then talk overall how you can fit Neo4j into your architecture. All right, Neo4j. Neo4j as a company actually is Neo Technology. We named our company Neo Technology, but more recently we're using Neo4j a lot more. So, but we have over 100 employees. Our headquarters is in Silicon Valley, but we have offices all around the world. Originally, we started in Sweden, in Malmo. We have over $45 million in funding. The product has actually been built over the last 15 years. The founders were working on a content management system for photographs, and they needed something that would be much more responsive to their queries when trying to find the right photographs for users of that CMS. And they designed a graph database. And so this was about 15 years ago, and over the last 15 years they built the product. Now we have over 150 enterprise subscriptions, including over 50 of the global 2000, but we also have many thousands more of users of our open source community edition around the world. So Neo4j has been adopted by a wide variety of verticals. One of the misconceptions about graph databases is that it's really just used for social applications, and although social use cases are the easiest to demonstrate in a way that everyone understands, because nearly everyone has a Facebook account or a Twitter account. Social use case is only one small amount of the overall usage of graph databases. Graph databases are very useful across a wide variety of industries, and you can see here we have everything from financial services to logistics and retail. And customers are using it for social, but they're also using it for recommendations. So retail recommendations or recommendations of content, search and discovery, network and data center operations, so building things that allow you to see the root cause of a particular outage, or if you're going to do maintenance on a router, what are the possible downstream effects as it affects users or applications. Things like master data management, identity and access management, which often has been done kind of forced into a tree structure in the past with technologies like LDAP, can also be accomplished much better with a graph database because the real world is not a tree. And then there are geo providers that are also using Neo4j. So we've been reviewed, and graph databases have been reviewed by a variety of different analysts, and they all are coming out with very positive statements about the effect of graph databases on companies. And Gartner here says it's the single most effective competitive differentiator for organizations pursuing data-driven operations and decisions. Forrester is saying that over 25% of enterprises will be using graph databases by 2017. And then EMA is saying they're the leader in graph databases. So there's a variety of analysts backing up the value of graph databases, and let's talk about that. First of all, the value in graph databases is about the value in data relationships. Traditionally, we've been taught to store our data in columns and rows in something like a relational database, And columns and rows aren't really how data exists in the real world. Data exists in the real world as sort of objects and the relationships between those different objects. And this data is increasing in volume. There's a lot of different processes and software that is now creating more and more data, and the data is getting much more connected. And using the relationships between the data helps us unlock a lot more value than just using the data itself. And early adopters of this technology became industry leaders. Folks like LinkedIn, Google, Facebook, they all use graph databases because that's how they can show the relationship between the data in a way that provides their applications a lot of value and their users a lot of value. Ironically, relational databases can't handle relationships very well. So you can't really model or store data and relationships without a lot of complexity. And that complexity, is seen as you have join statements and SQL statements overall that are dozens of lines of code in order to accomplish simple operations. Also, performance degrades with the number and levels of relationships and the overall size of the database. And query complexity grows as the different types of operations you're trying to do grow. Your queries get very long, and we're going to see examples of some of those long queries here shortly. And then, it's not very, able to be very maintained because as you add new types of data and relationships, you have to redesign your schema, and that really kind of slows your innovation overall. So this really makes traditional databases inappropriate when the data relationships are the key value and when you want to provide information about those data relationships in real time. So let's talk about modeling your data as a graph. Well, the first thing I want to talk about there is that the whiteboard model is the physical model. If you're as a business person, you're going to design the model of your data on a whiteboard, you're much more likely to design it like this than you are as columns and rows. You're going to design the different entities and how those entities relate to each other. And that's an important concept to keep hold as you design your database model as well. And that's what graph databases do. Graph databases keep the same model that you would put on a whiteboard as the model of the data in the database. Not only the model of the data in the database as your developers interact with it, but also how it's actually stored in memory and on disk. This is really important because it reduces the amount of translation between the business folks as well as the technical folks. And that reduced translation makes it a lot faster for you to iterate on your applications. So let's talk about that model and the different components of that model. First of all, we have nodes, and secondly, we have relationships. Nodes you can see here are like the person objects that you see. So those are nodes. Where you see the two people, those are nodes, and then the car is also a node. These are the objects, these are the nouns of your data. And they can have properties and can be labeled, and we're going to see how that works. The labels here are the words person and car. It's basically the descriptor of the category of node. And then the properties that they can have on it are seen here as the two people. We can see the first person has a name of Dan, the second person has a name of Anne, and they have their birth dates, and Dan has a Twitter handle. And these properties are easily added and removed without any schema design. And then we also have the relationships between the people. So in this case here, Dan loves Anne, and lucky for Dan, Anne also loves Dan back. And so those are relationships between different nodes. And those relationships can also have properties here. So you can see here that Dan drives this car, which Anne owns, but we can see here that Dan drives the car and has driven it since January 10th, 2011. So you can have properties on the relationships in addition to having properties on the nodes. All of the relationships in Neo4j are directional, and what that means is that when you create the relationship, you do have to specify the direction, but when you query the relationship later, you can either query it with a direction or without a direction. So talking about relational versus graph here, when you would store your data in a relational database, you often use a join table. In this case, I'm showing 3 tables here. In reality, you may just have 2, but you basically have a table that represents the objects, and then you have a table that represents the mappings between the objects, with no real sort of differentiation between those 2 tables, other than sort of what those columns contain. And this, creates a mapping that you need to do in order to figure out the relationships between the objects. Whereas the graph model, these relationships are much more inherent in the model itself. So in this case here, Andreas knows Tobias, Micah, and Delia. That's quite clear from just looking at the graph, whereas a relational model, it requires a little bit more analysis to see that, which is great for the developer that has spent many years learning this, but it is a learning curve that people have to overcome, and it makes it harder to do the translation between the business folks and developers. So let's model. Let's model a customers and suppliers and products, what we'll call master data, and the orders that those customers purchase of those products. And here's a very simple graph model. So in this case, an employee sold an order. That order contains products. A product is part of a category, and a supplier supplies the product. You can see very much how you translate the nouns into nodes and the verbs into relationships here. Except, the traditional way of designing this in your diagram, in your ER diagram, is something like this, where you represent each of these tables. They contain the nouns, but then you also have the mapping tables for the relationships, and that can get quite challenging. But we'll see here how we convert this ER diagram to Neo4j in a graph database. So we're going to give you an example using Northwind. Northwind is the SQL Server example. It is really the quintessential example of a relational database. But, it's not just any example. This is the quintessential example of a relational database, but this example can be shown to be accomplished much better in a graph. So we're going to convert Northwind to graph, and let's talk about how those relationships are represented and how those objects are represented. So here's 2 nodes. We have an employee and we have an order, and we're saying the employee sold a order. Very simple mapping. You saw earlier how we have nodes and relationships and the mapping between those. So the first thing that we're going to do as we try to translate our relational database into a graph database is locate the foreign keys that create the mappings between the tables. And those foreign keys become relationships. And so you can see here in the case of a supplier supplying a product, we have a supplier ID in the suppliers table. That simply becomes the supplies relationship. And they supply a product. And then you can see how a product is in a category. So a product has a category relationship to a category, and so forth. So it's pretty easy to take the foreign keys and make those become relationships between your different entities. And then in this case, you also have some simple join tables. So like order details, for instance, is the mapping table between an order and the products. but it has some additional information in it. So order details, it has the unit price and the quantity and the discount, and that can all be accomplished as properties on the relationship. So a order includes a product, and there's a couple properties on the relationship as to the unit price, the quantity, and the discount. So for today, we're going to be using just a subset of this data. We're going to be using the products, the categories, the suppliers, the orders, and the employees, and those relationships. Here's what those relationships look like. So we have an employee who sold an order. The order, it contains products. That's probably not the greatest name for the relationship that I have here, that the order products, I would say contains probably is more accurate. But then a supplier supplies a product, and then a product is part of a particular category. So let's talk about how we would query this data. First of all, before going into how we're querying this data, I do want to talk briefly about the syntax that you use to query data in a graph database. So you may all be, likely all are familiar with SQL as a syntax for querying a relational database. Neo4j has created a language called Cypher. And Cypher is, we'll say, ASCII art for graphs. It basically describes the relationship between your data in the form of your query. And we, had a choice to make when we designed Neo4j as to whether to use SQL syntax, which many people are already familiar with, or to use something that's a little bit more inherent in graphs. So as you see the Cypher syntax, we've chosen something that is very graph-like, and it may be a little odd at first, but after you get used to it, even over an hour, or certainly less than a day, it becomes a lot easier way to query your data. And here's actually a quote from someone on Twitter. Started messing around with Neo4j this weekend, and I'm beginning to wonder why SQL looks like SQL when it really ought to look like Cypher. And another quote from someone on Twitter, journey from SQL to Cypher, not so bad after all. 30 lines of stored procedure code into 3 lines of Cypher. Awesomeness. So this is something that people can pick up quite easily, especially if they're familiar already with something like SQL. So if we have a very basic query and you want to check who people report to, and in this case, we're going to try to find 2 very particular nodes. We're going to try to find the Stephen node reporting to the Andrew node. Here is our query. So we're matching an employee object, that's the label, whose first name is Stephen, that is a property, and how that employee reports to another employee object with a first name of Andrew. And it's a very simple syntax. You can see how it's like ASCII art. You see the arrow is basically through the relationship here. So you can see the arrow begins with a dash to the left of reports to and ends with the dash and the greater than symbol to the right of the reports to. It's creating that directional relationship. So your match statement is basically finding patterns in the graph. And in this case, we're looking at a pattern of a node with a reports to relationship to another node. And we're specifying a little bit more detail. Obviously, that's a very simple query, knowing exactly what we're looking for, but we'll see some more complex ones here shortly. So let's say we want to find who people report to in general. So in this case here, we're still using that ASCII art. We kind of switched the order around a little bit differently to have the arrow going the other direction with the less than symbol instead of the greater than symbol. And we're saying a subordinate, find a subordinate who is an employee label node who reports to a E who is an employee labeled node. And it's a very simple match statement here, and then we're going to return everything. And so if we do that using the Northwind data, you get something like this. Now, this is the first time I've shown the Neo4j browser. Neo4j, when you first start it up, comes with a built-in browser which allows you to run queries built into in a web application. And it allows you to run those queries and see either tabular results or results as a graph. And this is a very simple tool for everyone to use. You'll be guided right into it when you start out with Neo4j. And Neo4j now does include the Northwind data as well as part of the tutorial. So you can see the same data that we're talking about here today in this webinar. So this is kind of what, if you're looking at all the employees and who they report to, we can see this kind of cluster where there's essentially two managers. We have Andrew as a manager and we have Stephen as a manager, and then Stephen reports up to Andrew. And I mentioned also that you could return this as a tabular report, and this is what sort of the tabular report would look like. You know, because even though you're actually running your queries in a graph form, and Neo4j is taking the performance benefits of the data being stored as a graph, and you're getting the kind of productivity benefits of querying the data as a graph, in the end, many applications still want to use the data in a more tabular format. So you can query Neo4j from any programming language that you have. You can query it from Java or C# or Python or Ruby, and people have written what we call drivers or libraries for a whole variety of different languages. And so you can query that using HTTP-based API, passing in this Cypher syntax, and then getting the results back. All right, so let's get into a little bit more complex query, and this is a real query from a customer. Find all direct reports, say of a vice president, and how many people those people manage, up to three levels down. So a customer came to us with this problem, and they came to us with the SQL query that they were using for this. And here's what the SQL query was. I think this is 8-point font, and I'm not going to guarantee that this is the most optimized SQL in the world, but this is SQL that real developers are building inside the enterprise to run analyses like this. And in this case here, basically, because you have to go up to 3 levels deep, they're actually doing a number of different union statements here for each of the levels. Here is what the Cypher query looks like. Much, much easier to read, much easier to create, and much more maintainable, because all we're saying here in this match statement is find me a manager who reports to a boss up to 3 levels deep, and a report who reports to a manager up to 3 levels deep, where the boss's name, say, the vice president is John Doe, and then return the manager's name and their count of total reports. It's very readable if you can look at it as that sort of ASCII art form, where you're saying manager arrow boss, report arrow manager, and it's certainly much more readable than the SQL query that you all saw. So we've talked about maintainability and we've talked about performance. Let me give you a real quote from a customer. So Volker at eBay said that we found Neo4j to be literally thousands of times faster than their prior MySQL solution, with queries that require 10 to 100 times less code. And you all can think that 10 to 100 times less code means that the application is much more maintainable. So you and your team can go on to building new applications and services rather than spending all of your time maintaining your previously built applications. So today, Neo4j provides eBay with functionality that was previously impossible. All right, let's give another example here. We want to find the reporting chain for Robert. So we have an employee named Robert. We want to figure out what other employees that employee reports to. So Robert is our subordinate's first name here. So sub here is just an alias. You can use anything you want as long as it's descriptive for helping you use those values in your where clause and your return clause. But in this case here, we're looking for a subordinate employee whose first name is Robert, who reports to any number of levels. That's what the asterisk says. So we have reports to asterisks. That's saying any number of levels up to another employee, and then return that path, the full reporting path. And that gets us something like this. On the left-hand side, we're seeing Robert reporting up to Stephen, and Stephen reporting up to Andrew. And so that's the reporting path of the employees whose name is Robert. Again, you're seeing this in the Neo4j browser. You can download and install Neo4j rather quickly and get up and running with the Northwind data to try this out yourself. So let's say we want to figure out who the big boss is. Who do we have in our graph that does not report to anyone else? So in this case here, we're saying find me the path where there is not a relationship between that employee and reporting to someone else. And that will get us the big boss. And in this case here, the big boss's name is Andrew. Again, very simple queries to run, and it's also quite easy to read these queries. So that's helpful. And so we've talked about kind of the employee reporting chain and things like that. I talked earlier about how often Neo4j and graph databases are used in identity and access management. So you can imagine this employee data also being used to allow someone to log into an application and things like that, or used in your ordering system in master data management. But you can have this, the same data here used to represent how those employees interact with your customers and your suppliers and applications within your enterprise. So now let's talk about the products themselves. So what if we want to find the cross-sell between different products? So in this case here, how do we find the products that are sold along with the product called chocolate, and how many times that they're sold along with that product and by different employees? So here's what the query looks like. We're saying an employee sold an order. That order has a product, which product name is chocolate. And that employee sold a order which has products that are other than chocolate. And then return the list of employees' names, the products' names, as well as the count of those cross-sold products. And that returns something like this. We're viewing this in the table mode because that makes the most sense for this type of data. And we're seeing here the employee's name, the product's name, and then the count of overall number of times that those products were sold along with chocolate in the same order. So we can see Nancy sells a product whose name I am not going to try to pronounce at the total of 37 times along with chocolate. And Margaret sells a lot of different things along with chocolate, crab meat, pâté chinois. Again, I should stop trying to pronounce these. All right, but that's a very typical type of query that our customers want to do when they're using Neo4j to store master data about orders and the relationships between their employees and orders. So we've talked quite a bit about how Neo4j is easier to represent, makes it easier to represent your queries, how it makes your queries a lot more maintainable because they're more easily represented. And I also want to talk a little bit about performance. So Neo4j essentially stores your data on disk in the form of a graph. And what that means is that as you travel the relationships, you get this advantage called index-free adjacency. It means as you try to traverse the graph, you are not looking up in indexes for each traversal. It's essentially doing pointer arithmetic to get from one node in the graph to another node in the graph, which is a lot more performant than looking something up in an index. Whereas a relational database, when you have your join statements, you are going to be using indexes to look up the mapping of those relationships. And where this takes hold is as you're traversing a large graph. In this case here, we're looking at a graph of users, and there are 100,000 users and 5 million relationships. And this is a Cypher query for saying, find the size of John's fifth degree network. What different paths can you go to get to John's fifth degree network? So although there are 100,000 users, there are actually 312 million different paths you can take to traverse those users in this data set. Now this query took 5 minutes and 30 seconds. Not great by my opinion, but is an example of what sort of an unoptimized query took to get this information. Now, this is the unoptimized one. You're going to see the optimized one here shortly. But first, I'll show you sort of the unoptimized version of a SQL query for something like this. In this case here, we're finding the size of John's fifth degree network in SQL, and we're basically doing the joins between all of these different tables. And that took 1 hour and 55 minutes to get the same result. Now, in an optimized sense, on the SQL query, we can only count on the join table instead of joining back onto the user table to count the actual users. And in this case, you can get the SQL query down to about 2.5 minutes. However, if we optimize the Cypher query, and instead of on the last relationship, instead of actually traversing that relationship, we just count how many of those relationships exist. So you can see that here with the size of F4 query here. We end up with the same result of 312 million, and the query only takes 12 seconds. So a couple minutes to 12 seconds is a dramatic performance improvement and really demonstrates the value of Neo4j and of storing your data in a graph database when the relationships are things that you really, really care about. Now, in terms of the overall architecture of Neo4j, we have an architecture that's based off of a cluster, which gives you huge read performance benefits when you're running your queries. And this is available in the Enterprise edition of Neo4j and allows you to have master-slave replication and failover to get both performance as well as reliability that you're looking for. And we've also worked on optimizing getting your data into Neo4j. So Neo4j has a couple different ways of importing data. In the latest 2.2 release, we created a Neo4j import command that allows you to load your data in bulk. And you can see here we've loaded over 4.58 million things in the relationships in about 100 seconds. So it's really easy to get your data into Neo4j. Your data is coming into Neo4j usually as a CSV format file. We kind of picked the lowest common denominator here of data formats. Although many people hate CSVs, it's really easy to work with CSVs from a variety of different applications. And that's why we use it to get data into Neo4j. So you can choose to get your data into Neo4j in a variety of ways. We have some customers who migrate all of their data from relational databases into a graph database. And then we have other customers who continue to use their relational database and look at the data where there's a lot of relationships, where they're performing lots of joins on the data, and put that type of data into the graph database. And then lastly, we have customers that really just duplicate all of their data and have it in both databases so it can be queried in whatever form is the most optimal for the types of queries that people are trying to run. So if you think of Neo4j and you think of your applications can access Neo4j over an HTTP API, sending those Cypher queries from any programming language. And you have the end user interacting with those applications, but then you also have those other databases. Like I was mentioning on some of the previous slides, your application can actually interact with other databases in addition to interacting with Neo4j. So in this case, we are saying other databases, other relational databases or NoSQL databases, or things like Hadoop infrastructure for big data processing. And then you can also use Neo4j as an analyst and interact with Neo4j data directly as well as through sort of bulk analytic infrastructure. And this slide actually brings up a really good point that many people think of Neo4j as for analysis. And Neo4j is great for analysis, but it's primarily intended as an OLTP. It's intended for your transactional data to make real-time queries and updates of your transactional data. So, you can use it to run queries from an analytical perspective, but it's really meant to make live decisions from your applications based off of your transactional data. Speaking of polyglot persistence here, we also have customers that are using Neo4j along with things like Mongo. So in this case here, a customer called Wanderoo, who does sort of travel trip planning, is using Mongo to store the routes for the different trips and all of the details about the routes, rather large documents, as JSON formatted data in Mongo. And then they are synchronizing data using the Mongo connector with a custom doc manager that they've written over to Neo4j to run the route querying. So the route querying is much better performed in a graph database, so they wanted both Mongo as well as Neo4j in their infrastructure. And this is a fairly common solution where people are mixing the different data sources together. So Wanderoo used a custom Neo4j doc manager with Mongo connector, which does sort of live syncs. As a new record gets created or updated in Mongo, it live syncs that data over to Neo4j. We're actually currently working on a Mongo connector ourselves that it is more sort of generic, meant for different data sources that you may have in Mongo, as opposed to the kind of custom one that the Wanderoo folks initially wrote. And so we're doing that as an open source project, and you can feel free to reach out to me on Twitter at RyGuyRG if you want early access to that. We're about ready to get that out to a handful of folks right now, but it is a really great way to get the benefit out of both types of databases, your Mongo database for your documents and the larger document data, and Neo4j for the relationships between those documents and data. Wanted to share a few more quotes for you about how folks love Neo4j. So we have at the top left here John Resig, the creator of jQuery, who really loves Neo4j, is a really active enthusiast on Neo4j, and talks about that quite a bit. He has turned in a bunch of complicated analysis scripts into a handful of simple Cypher queries. And then other folks who have really found that Neo4j makes it a lot easier for them to work with their data. It's funny, I don't have this quote on here, but we actually had one user that was like, SQL made the first 15 years of his software development career a lot of fun, and he predicts that Cypher will make the last 15 years of his software development career a lot of fun. And so that's really, it may look a little bit odd at first, that ASCII art for graphs, but you can get used to it very quickly and get to loving it and be a lot more productive of a developer. So as you want to get used to Neo4j and get started, I would encourage you to just go and try downloading, installing, and running it. I actually, when I first started at Neo4j, I came from a background of cloud computing, and I was used to cloud services being the easiest way to get things up and running. And I looked at an installed database like Neo4j as something that would take a little bit of time to get started. But I proved myself wrong by proving that you can download, install, and get the Neo4j browser that you saw up and running in less than 1 minute. So take a look at that and just try it out. Just try out playing with various data, including the Northwind data set that we talked about. It's pretty quick to deploy your app. We have customers deploying apps in as little as 8 weeks. If you are interested in the Enterprise Edition of Neo4j, we do also offer professional services to help you get up and running very quickly. And then, regardless whether you're using Enterprise or the Community Edition, there are a lot of great resources online to learn Neo4j. There are meetups in many cities around the world. There's Stack Overflow, which is sort of the canonical way to ask questions on software development and find answers. We participate in that, and other Neo4j developers participate in that quite actively. And then, there's online training. There are training classes that we hold in various cities around the world as well. And there's groups and books. There's an O'Reilly book that you can download for free on graph databases. So a lot of different resources that you can use to get started. And a lot of people are out there just like you, downloading Neo4j, getting started learning about Neo4j through our educational resources and joining meetups. So I encourage you all to join the community and let us know what you've built. So get started now. Go over, download Neo4j, get started with some of those Northwind queries perhaps, or you can look up the term GraphGist, GraphGist, and you can find a variety of different data sources out there that people have built and made into sort of tutorials, single-page tutorials showing you the business problem, the data, and then how to solve it in Neo4j. And if you have any questions or looking for any particular types of data for your use case, feel free to reach out to us online as well. So in summary, Neo4j is about taking relationships and connected data seriously. Make it really easy to model your data and get serious performance of your data. It fits into your enterprise architecture alongside your other databases or your analytics services or things like that. And it's pretty easy to get started and reap the benefits quickly.